I'm going to look at a problem from May of 2008. You have a base barium hydroxide added to an acid, nitric acid, you produce salt and water, a neutralization reaction. So you have 25 cm cube of barium hydroxide, concentration of barium hydroxide is given, which reacted completely with 28.7 cm cube of your acid. The first question is, what is concentration of nitric acid? 3 points. First, I have to find moles of barium hydroxide from the information I have, then moles of nitric acid, and finally, I'm going to divide it by its volume and give the concentration. So let's find moles of barium hydroxide. Moles of BaOH2 is nothing but concentration times volume. Concentration is 0.146 mole per dm cube. Volume, you have to convert it to decimeter cube, 3 decimal places to the left, so it's 0.02500 decimeter cube. When we do this, your answer will be 3.65 times 10 to minus 3 moles of barium hydroxide. And you get your first point from the 3-point question. Second thing I need to find is moles of nitric acid. Some of you will see it. It's 1:2 ratio, so it's twice as much. I'm going to solve for it if you don't mind. So it's 3.65 times 10 to minus 3 moles of barium hydroxide in my problem. And in any generic balanced equation, it's 1:2. So balanced information will say for every 1 mole of barium hydroxide, I have twice as much 2 moles of nitric acid. And I stop here and I do my calculation, twice as much, so this becomes 7.30 times 10 to minus 3 moles of HNO3. And I get my second point from 3-point question. The last is, what is concentration? It's moles divided by volume. For nitric acid, so I take moles of nitric acid, which is 7.30 times 10 to minus 3 moles. I divide by its volume, which is in cm cube. I take 3 decimal places to the left, which is 0.0287 decimeter cube. When I do this division, you should also do it. You will get 0.254 mole per dm cube. Final answer and the final point of the 3-point question. Now, the next question is related to the equation, has nothing to do with your neutralization, with the problem you solve. So I'm going to use red ink and solve it. In this case, you have 0.142 moles of nitric acid, and you have 0.107 moles of barium hydroxide. The question is, how many moles of barium nitrate do you produce? So first thing I have to do is find my limiting reactant. And I'm going to take go after barium hydroxide first. So I have 0.107 moles of that. I divide by its coefficient, which is 1. Then I go after moles of nitric acid, which is 0.142 moles, divide by its balanced coefficient, which is 2. Definitely this is bigger than that, so this will indicate that HNO3 is limiting. Then it's easy, it's 2:1, so if you divide this by half, you get your answer, which is the same ratio. But if you don't mind, then again, I like to solve it. So I'm going to say I have 0.142 moles of HNO3 to start with. From balanced equation, for every 2 moles of HNO3, I give you 1 mole of barium nitrate. So 2 moles HNO3, 1 mole BaNO3 twice. So this is half as much, and it's happened to be 0.0710 moles of your product barium nitrate. Now the question continued this year. Let's go to the next page. Although it's totally unrelated, but they use the product as example. They say you have 0.01 moles of this, and the question is, use the ideal gas equation, calculate the volume of the gaseous products. Now there are two gases. If we find moles of the gases, then we can just stuck it into PV equal nRT. So what I'm going to do is first find moles of NO2, then moles of oxygen, then I'm going to add it and plug it into one equation, because gases identity is not important to contribute to the volume. So let's find moles of NO2 first. 0.01 moles of barium nitrate times, for every 2 moles of barium nitrate in denominator, I have 4 moles of NO2. So let's stop here. 4 divided by 2 is 2. 2 times that number, so you will produce 0.02 moles of NO2, nitrogen dioxide. Now let's go after oxygen. 0.01 moles of barium nitrate again. This time it will give you half as much of oxygen. For every 2 moles of barium nitrate from balanced equation, you produce 1 mole of oxygen. So 0.01 divided by 2 is 0.005 moles of oxygen. Now if you add this, the moles of gases is simply 0.025 moles. This is the only tricky part in this question. Then we are going to calculate volume, so PV equal nRT. I'm interested only in volume, divide both sides by P. So volume is number of moles of the gases, in this case 0.025 moles, times gas constant 8.314 kilopascal dm cube divided by mole divided by Kelvin, times temperature in Kelvin. They gave it to us in Kelvin. The entire numerator divided by the pressure in kilopascal. So 3 decimal places to the left, 1.2 times 10 to the power 2 kilopascal. If I do this, my final answer will be in decimeter cube, 0.720 decimeter cube. But they want it in centimeter cube. Every decimeter cube is 1000 centimeter cube. Therefore, the volume of gases is equal to 720 centimeter cube.